going to continue to solve equations with trig functions, but this particular section we're going to be working with inverse trig functions. Now there's an important thing that we need to remember here is whenever you square both sides of an equation, now when we say square, that would mean something like to the second power, not square root. You have to check for extraneous roots. It's not an option. It's not like you can check your answer if you want to. You have to check for extraneous solutions or extraneous roots. Now these extraneous roots appear sometimes because when you square both sides of an equation, if you square 2 you get 4, and if you square a negative 2 times a negative 2 you get 4. So what ends up happening is we don't know if the original root came from 2 or negative 2. So that's what it means to solve for those extraneous roots or extraneous solutions, or check for them. So to get started, as usual, we need to know our unit circle. That's going to be very, very important. And knowing your unit circle is going to be really paramount here. We can also check some solutions on your calculator, and I'll show you how to do that as well. But you need to be able to do these by hand and know your unit circle, and then use your calculator to check, not to do your work. So let's go ahead and get started with here. 3 arc cosine of x equals 2 pi. So the first thing we want to do is we want to isolate the trig function. So we'll divide both sides through by 3. So I have arc cosine of x equals 2 pi over 3. So what we can do from here is we want to clear this arc cosine. We want to just be left with the x. So what we'll do then is we'll take the cosine of both sides. Now the effect of this would be that we're canceling the arc cosine and the cosine. They're inverse operations of each other. So this is how that will look. Now what happens again, the cosine and the arc cosine cancel each other out, they undo, and so I'm left with x on the left hand side, and then the cosine of 2 pi over 3 is pretty simple to work with. This is just basic knowledge of our unit circle, and the cosine of 2 pi over 3 is in the second quadrant, so quadrant 2, where cosine is negative, and the cosine of 2 pi over 3 would be a negative 1/2 then. Now we didn't square both sides of the equation, so I don't have to worry about checking for extraneous roots. So that's my solution. Now if you wanted to check this, let's go ahead and pull in the calculator. What we could do here then is we could plug this into our original. So 3 inverse cosine or arc cosine of x. Well, we got x to be a negative 1/2. Okay, and hit enter. That's the left hand side. The right hand side is 2 times pi. So let's go ahead and enter that. 2 times pi. It looks like they're going to be equivalent. If you notice, both sides are equal, so this does check. So I would take the time to always check your answer on your calculator, but again, it's not a substitute for doing the work by hand, so make sure you remember that you have to show your work to get the credit. Okay? Now another way that we could do this same solution is we could actually graph this. So this is showing, this is our check that shows that this is the correct solution. Let's go ahead and graph this as well. So what we do is we graph 3 inverse cosine of x. We can use our shortcut key of x, close parenthesis, and then I have to subtract over the 2 pi. Well, the reason we have to subtract it over is we have to get it set equal to 0. So let's go ahead and copy and paste this one into our lecture as well. Notice we're in radian mode up here at the top, and that's going to be very important. Now to graph this, we may have to widen. No, this looks like it'll work. I think I want to kind of see a little bit more on the left though. So I'm going to go to Window, and I'm going to go -5 to +5, and then my x scale is 1. That's fine. So I can see that it's crossing right here. What I don't know is if it's exactly at -1/2 or not, so I need to find that decimal approximation. So I'll go ahead and go second calc, right above the trace button. We go to 0, the second option, because I want to know what the 0 of the function is, left bound. And the 0 of the function means the root or the solution. Right bound. And we can see it's 0.5 here, so this does check. So you can check your answers for sure on your calculator, but again, you have to be able to show that work by hand as well for credit. So we've shown this quite a few ways that the answer definitely is -1/2. We've done it with the calculator, we've checked our work with the calculator, and we've worked it by hand. So this point where it crosses is -0.5. So that checks here. So that's an example of an equation, solving an equation using an inverse trig function. Now we can set these up quite a few different ways. Let's go ahead and look at our next example. Well, this next one has two inverse trig functions that we'll need to work with. So what we want to do is we want to get x by itself on the left-hand side. So the way that we can do that is to take the cosine of both sides. Because again, the cosine and the inverse cosine are inverse operations of each other, so they cancel each other out. And you're just left with the x. So over here on the right-hand side, I'll have the cosine of the inverse sine of 3/5. So definitely the left-hand side here is easier to work with because it's the cosine of the inverse cosine. They undo each other, and I'm just left with the argument of the trig function. Now this piece right here, remember inverse sine of 3/5. This is a question. This means what angle in the interval from, this is bracket, -π/2 to +π/2 has a sine of 3/5. Now this is not a common angle that I know, so I'm just going to say that's theta. So this entire expression right here can just be simplified down to cosine of theta. Well, what I can do is I can take the information from here, draw out our right triangle, mark our right angle. Remember, angle theta is what I said that we're looking at here. And theta, sine of theta then, is 3/5. That's the meaning of the inverse sine of 3/5 here. So sine is opposite over hypotenuse. And then my missing leg would be square root of 25 minus 9. The square root of 16 is 4. Okay, and that's just Pythagorean's theorem. So then I have x equal cosine of theta. Cosine of theta would be adjacent over that hypotenuse. So I get x is equal to 4/5 here. So I'm using some information from previous sections as well, but the new addition here is taking the cosine of both sides and then working with the cosine of an inverse sine as well. These can be a little bit tricky, and every problem is slightly different, but that's one of the strategies that we can use, is to use that idea of taking the cosine or the sine of each side to get x by itself to start solving for one of these equations. So this equation, we have two inverse trig functions as well, inverse sine and inverse tangent, but the other one, I had a variable inside the inverses. So this one's a little bit different because the inverse tangent of 3 I can actually solve for. So let's go ahead and look at this inverse tangent of root 3, I should say. This means what angle in the interval from negative to positive π/2 has a tangent of root 3. Now this is one that we know. This is from our standard angles, and so what we can go then is the answer is π/3. So when I rewrite this, then I end up with the inverse sine of x minus π/3. The minus comes from the equation that's given to us, is equal to a negative π/4. I want to isolate inverse sine, so what I'll do here is I'll add π/3 to each side, and I'll have the inverse sine of x equals negative π/4 plus π/3. And of course we need to find a common denominator. It'd be 12 in this case. So I'll multiply top and bottom by 3 on the left and 4 on the right. And I'll have the inverse sine of x equals negative 3π/12 plus 4π/12. Inverse sine of x is equal to negative 3π plus 4π is π/12. Okay, so now π/12 seems a little bit familiar to me. This is when we were using the sum and difference identities. So if you have your note cards or the formula sheet from the last exam, those would be good to get out right about now. Now what is the meaning of this? This means what angle, okay, so what angle has a sine of x? That's on the left hand side. Now on the right hand side, I have just the value of pi over 12. So this is saying that the sine of pi over 12 is equal to x. What angle has the sine of x? Pi over 12 does. The sine of pi over 12 is x then. Now pi over 12 is not a standard angle that we're used to working with. However, I can work with two angles, pi over 4 minus pi over 6, to get pi over 12. And then this should seem familiar. This is the formula that we would use, something like the sine of a minus b. And from your formula sheet, this is sine a cosine b minus cosine a sine b. So that's what we're going to do here, is we're going to plug in these values of pi over 4 and pi over 6 into the formula. So this is equal to the sine of pi over 4 cosine of pi over 6 minus the cosine of pi over 4 sine of pi over 6. So this is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2, and the sine of pi over 6 is 1/2. So this would be root 6 minus root 2 all over 4. Okay, so this works out pretty slick. I could find a decimal approximation for this if I wanted to, and I could solve this with a decimal by graphing, and then I could compare what I get for my graph decimal approximation to my root 6 minus root 2 if I wanted. So let's go ahead and try that. So I'm going to graph the original. So go to y equal. See if I can make this a little bit bigger. Okay, so here I'll put in arcsine of x minus arctan, and the arctan would be at the square root of 3. Now that's the left hand side. Now what I need to do, this negative pi over 4 that's on the right, I need to add it to both sides, because again I have to have this all set equal to 0. So this would be plus pi over 4, and if you want to use your fraction key you can. So this is what I'm trying to graph. I am in radian mode, so that's always good to check. And most problems it seems like you'll be working in radian mode. And when you get into calculus you'll almost always be in radian mode. So again, this is our check. This is what we're graphing. So let's go ahead and graph that. We may have to adjust. Well, we don't need to adjust at all. We do see that it crosses once. If I want to figure out what this value is, we go to second calc. I go to the second option here, the 0. The 0 means where it's crossing. I'm to the left of the point, so I can just hit enter. Now I move to the right of the point. It can be anywhere to the right of the point. And I get this value of 0.258819. Well, there's that snipping tool. Sorry. It's kind of jumping around on my screen here. Let's see if I can get that out of there. There. I'm having a heck of a time here. Okay, let's get the calculator back up. There. Now we've got things in the right order. So again, I am in radian mode, so that's important. And I can see that my decimal approximation is right here, the 0.258819. So what I'm going to do next then is I'll figure out what my decimal approximation is for root 6 minus root 2 all over 4. So we're going to go alpha y equal, and this will be root 6 minus root 2, and this is all over 4. And decimal approximation is 0.2588. I'll copy that and see if it is equal. And they are 0.258819, 0.258819. So even though I can't do the problem straightforward and get the root 6 minus root 2 over 4, I can do the handwork, and then I can compare the decimal approximation to the solution that I get from graphing. So I think that's worthwhile to do and practice that when you're doing your homework, because on the test you can do the same thing, and if you've practiced it during your homework problems, it'll be a little bit easier process for you. Let's go ahead and look at another example. And again, with most of these examples, we have to just remember we're trying to isolate one of the variables, and we usually want to do when the argument is just equal to x, because then I can solve for that by taking the inverse cosine or the cosine as shown in this example. Okay, so to get started, what we can do is we can take the cosine of both sides. So this would be the cosine of the inverse cosine of x equals the cosine of the inverse sine of 5/13. Now this looks a little bit familiar to me. The cosine and the inverse cosine are inverse operations of each other, so this is going to be equal to x. And then on the right hand side here, this piece right here, that is what angle in the interval from negative to positive pi over 2 has a sine of 5/13. And I don't know, I'm going to just call that angle theta because I don't know what angle has that. Okay, so let's go ahead and put in a theta here. So we're looking for the cosine of theta. Cosine of theta again is adjacent over hypotenuse. So what I need to do is I need to draw up a right triangle, mark my angle theta. So the sine of theta is 5/13. That's adjacent over hypotenuse. So this would be 13 squared is 169. 5 squared is 25. I'd subtract 169 minus 25 is 144. And the square root of 144 is 12. So adjacent over hypotenuse. Okay, I have these backwards. Sine is opposite over hypotenuse. And this is my adjacent side. So the cosine would be 12 over 13, the adjacent over the hypotenuse. So this works really slick. And again, this looks pretty familiar with the problem that we've already done. But remember, we're trying to isolate a variable, in this case by taking the inverse cosine or the cosine of both sides. It's kind of a straightforward way that we usually do that. Let's go ahead and look at a few other problems. Some of these can get pretty involved, and we haven't even followed one so far that follows that rule of whenever you square both sides of an equation you have to check for extraneous roots. But this one might be the one. So let's try arc sine of 6x plus arc cosine of x equals pi over 6. Now in this case I can't take the inverse sine of both sides because this is not by itself yet. So I think the first thing that we need to do is we need to go ahead and isolate the arc sine of 6x. So let's take the arc sine of 6x equals pi over 6, and I'm going to subtract over the arc cosine of x. Okay, so again I'm going to isolate the arc sine of 6x by subtracting over the arc cosine of x. Then what I'm going to do is I'm going to take the sine of both sides. So I'll have the sine of the arc sine of 6x equals the sine pi over 6 minus arc cosine of x. Okay, so we just took the sine of both sides. Now what ends up happening here is the sine of the arc sine are inverse operations of each other, so they undo each other. So I'm left with 6x on the left, and then on the right I'm left with the sine of pi over 6 minus the arc cosine of x. Okay, now let's think about this. Arc cosine of x, what does that mean? This means what angle in the interval from 0 to pi has a cosine of x, and I don't know what that is, so I'm going to call it theta. Now this means that the cosine of theta then would equal x, and of course x is the same as x over 1, adjacent over hypotenuse. So really what we're looking at here then is 6x equals the sine of pi over 6 minus theta. And we have a formula for the sine of the difference of angles. So what we're going to do is we're going to use the sine of a minus b. And the formula for the sine of a minus b is sine a cosine b minus cosine a sine b. Okay, so we'll just fill that in from here. Don't forget the 6x, I can't drop that. So this would be the sine of pi over 6 cosine of theta minus the cosine of pi over 6, the sine of theta. Now, I know what the sine of pi over 6 is. That's that nice little 1/2. I don't know what the cosine of alpha or theta is. I do know the cosine of pi over 6 is square root of 3 over 2. So I need to plug these in. Now, the way I'm going to figure out what the cosine and sine of theta are is by drawing up my right triangle from this information right here. So let's go ahead and do that. Mark your right angle. Here's my angle theta. This is adjacent over hypotenuse. So my missing side would be root 1 minus x squared. And again, that's just using Pythagorean's theorem. So now from here, the cosine of theta, I can get from my graph or my picture here, or just from looking right here, is just x. And I can think about that as x over 1, so it has a fraction as well. Now here I have square root of 3 over 2. Sine is opposite root 1 minus x squared over hypotenuse. Okay, so let's see what this simplifies to. So I have 6x equals x over 2 minus the square root of 3 square root of 1 minus x squared all over 2. Now just to make this a little bit easier, I'm going to multiply both sides through by 2 to clear those fractions. So 2 times 6x is 12x equals, again these 2's canceled, so I'm left with x minus the square root of 3 square root of 1 minus x squared. So what I'm going to want to do next is I'm going to want to isolate the radicals so I can square both sides. So I'm going to start this process by subtracting x from both sides. So I'll have 11x equals negative square root of 3 root 1 minus x squared. Now this is that important step. If you square both sides of an equation, I'm going to have to check for extraneous roots. So as soon as I square both sides, this means I have to check for extraneous roots when I'm done. Okay, so on the left hand side I'll have 121. 11 times 11 is 121 x squared. Now on the right hand side I can take this square and distribute it through a product. If this was addition or subtraction, I couldn't do it. So negative root 3 times negative root 3 is a positive root 9, and the square root of 9 is 3. And the square root and the squared would cancel each other out, and I'll be left with 1 minus x squared. So I have 3 minus 3x squared. And then what I'll do is I'll get all my x squareds on the left by adding 3x squareds to both sides. So 121 plus 3 is 124. X squared equals 3. Divide both sides through by 124. And I have x squared equals 3 over 124. Now the next thing we're going to need to do is to take the square root of both sides. So I have x equal plus or minus. Remember, you have a primary root or a principal root and the negative root. So this would be root 3 over 124. So it's the square root of the 3, the square root of 124. Now this does simplify. I still don't have any information so far about which of these roots that I'll want. We'll talk about that in a minute. So plus or minus root 3 over root 124. Now I can simplify root 24 into root 4 root 31. So I get x equal plus or minus root 3 over 2 root 31. Now of course we'd rationalize the denominator. This problem's getting kind of long. and we'd get x equal plus or minus the square root of 93 over 2 times 31 is 62. So I have two solutions here. I have x equal negative root 93 over 62 and x equal positive root 93 over 62. Now these may or may not both be right. I have to check. Okay, so let's go ahead and check these. I think the easiest way to check these would be to plug them in to your calculator. Another way you could check them is by graphing and getting a decimal approximation. So we have two different things that we could do here. So let's go ahead and rewrite the original equation, because that's way up on the other page, I think. So our original equation was arcsine of 6x plus arc cosine of x equals pi over 6. Okay, so let's go ahead and check these. So I'm going to check my x equal, I'll check the positive one first. It doesn't matter which one. I'm just going to start with the positive. So when I check this, what I'll do is I'll plug it into the arc sine of 6x. So x in this case was root 93 over 62 plus arc cosine of x. X was the root 93 over 62. And I'm wondering, I'm going to put a question mark here, does this equal pi over 6? Okay, so let's go ahead and grab the calculator and start plugging this in. So on the left hand side I'll have the arc sine, and I'll use my fraction key, the alpha y equal 6 root 93 in the numerator. The denominator is 62, close parenthesis, plus arc cosine, and I'll use my fraction key again, root 93 over 62. So this is going to give me a decimal approximation. Always check that you're in radian mode, and we are here. It's going to give me the 2.61799, etc. So that's the left hand side. Now what I want to know is this equal to the right hand side, and the right hand side is equal to pi over 6. So I basically need a decimal approximation for pi over 6 now. So I'll have, I can do my fraction key or not, it doesn't matter here, pi over 6. And my decimal approximation is 0.523598. And these are not equal. So that's not a solution, that's an extraneous root. Okay. So I think I want to do is get rid of that other one with just the one number. I want the one with both solutions. Okay, so what I have found out here, that these are not equal. And because they're not equal, this is no solution here. Not a solution. Okay, so now I check the next one. So now I will go ahead and check x equal negative square root of 93 over 62. So plugging that in, that would look like arc sine of 6 times root, I'll put the negative out front, negative 6 root 93 over 62 plus arc cosine of square root of 93, and again we're checking the negative 1 over 62, and I'm wondering, is this equal to pi over 6? Well, this will be easy to check because I should just be able to go in and edit what I already have in my calculator. So I'm going to go up top, hit enter, and then I'll come over here and I'll put in a negative sign. Not a minus sign, but a negative sign. I'll do that for both of these. Now if you notice, this is equal to the pi over 6 above, so this is a solution. So if you don't check, you might write down both as answers, and they're actually not. One of them is an extraneous root that's created when we squared both sides of the equation. So because these are equal, this means this is our solution. So that was a pretty long problem. It's pretty involved. So it's really important when you're working through these that you show everything step by step and kind of be very, very careful and methodical about how you approach a problem. For our last problem that we're going to look at a little bit of a story problem. Okay, so for this one it says the equation for the angle formed by a rhythmically moving object, and the angle is y, so let's keep that in mind. It's hard to keep track of all these variables, so let's keep that in mind. So the angle is y, is given below, where t is time. That usually makes sense. And so this is our equation. So we have y equal 1/6 sine of 7 pi t over 6. Now part A says to solve the equation for t. So if we solve this for t, I think the best way to start would be to multiply both sides through by 6 to clear the fraction. Okay, so the 6's cancel on the right. So I'm left with 6y equals sine the 7 pi t over 6. Now we need to get into that t, but we can't do anything with it as long as there's the sign there. So what we'll do to get rid of the sign is we'll take the inverse sign of both sides. We'll kind of undo that operation. Okay, so let's see what we have on the left-hand side here. The inverse sine of 6y, nothing that happens there. But on the right-hand side, the inverse sine and the sine, they cancel each other out to just leave me with the argument of the trig function, which was 7 pi t over 6. Now we're trying to solve for t. We want t to stay, so I'm going to multiply both sides by 6 over 7 pi. 6 over 7 pi. And the reason we do that is so the 6's cancel and the 7 pi's cancel. So I'm left with t equals 6 sine inverse of 6y. Let me write that a little nicer. All over 7 pi. And that's what t is equal to. Now part B says to evaluate this and find out what time t does the object form when we have an angle of 0.1 radians. Well, remember, y is the angle. So for part B, I'll have t equals 6 inverse sine of 6 times 0.1 divided by 7 pi. Now this is not 6.1, it's 6 times 0.1. So there's a big difference there. So let's go ahead and plug this into the calculator, and we have to be pretty specific about how we plug this in. We want to use that fraction key if you have it. So this would be 6 inverse sine or arc sine, 6 times 0.1, which would be 0.6. So you can either put in the 0.6 or 6 times 0.1, either one. Just don't put in 6.1, that's not correct. Divided by 7 pi. Okay, so here's our decimal approximation for this one. It's 0.1755, etc. We'll copy and paste that in. And again, we're in radian mode, so that's important to remember as well. So this is our solution, the 0.1755, etc. Now in my math lab, they'll probably tell us to round this to 3 or 4 places. So remember that you need to round appropriately, so don't forget to do the rounding. As usual, if you have any questions, please let me know. These are pretty straightforward, but again, you really have to show all the steps because these can get a little bit long. And remember, anytime you square both sides of an equation, you have to check for extraneous roots or extraneous zeros. So make sure you do that. If you have any questions, please let me know. You can just shoot me a screenshot and I'll help you out. Good luck.